Hello everyone, welcome to the next lecture on the non-parametric testing. Today we will discuss about what is the KS test called as the Kolmogorov-Smirnov test. We will see in this three-step rule how you can solve this problem. Myself, Dr. Garg, working in the School of Mathematics, Thapan Institute. You can simply contact this either of the email IDs if you have any doubt. So this test is basically used to compare if you want to compare any of the distributions which are based on the samples and the theoreticals. So make sure that here is the distribution which is called as the cumulative density function. So this is the KS test which is based on these two probabilistics are there. That is, first is Andrew, and which is born in 1903, and this one is 1900. The purpose of this test is to know how you can say your hypothetical distribution function fit on the empirical distribution function. Now here the question arises is, what is the empirical distribution function? So let me firstly introduce you what is the empirical distribution function. If you have some observation, say xi's, then the empirical distribution function is nothing but the fraction of the sample observation, because it's a distribution. So what is the definition of the CDF? This is all of you know about this one. That is fraction which is less than or equal to the value of x. How you can find the empirical distribution is, if you have some observation, you can write in the ascending order firstly. Once you are writing this ascending order like here, make sure that no values are in the repeated. Then you can define this empirical distribution as f of n is k by n if it lies between them, otherwise this is 0 and 1. For example, if you have say a random sample of the 8 people which have the following here, how you can define the empirical distribution for this function? It's a very simple are there. So firstly you have to define say x is say number of the times they reads in the past month. How many values are there? It has say unique value, that is a 0, this is a 1, this is a 2, this is a repetition, so I can write here. What is the frequency corresponding to this is, how many times a 0 is a 1 time, 1 is again 1 time, 0 is my 2 times, this is my 1 time, this is my 2 times, this is my 1 time. So what is the total number is are marked there? So this is the 4 plus 4 is 8. Corresponding to this frequency, can you define the PDF? You can easily define the PDF. This is nothing but my 1 by 8, total is my 8, this is 1 by 8, this is 2 by 8, 1 by 8 and so on. That is, you can define the PDF. Also you can define the CDF from here. This is 1 by 8, 2 by 8, 3, 4 by 8 and then so on. This CDF is called as my empirical distribution function, that is called as f, and n is my 8, so empirical distribution here. Now based on this empirical distribution we can see this KS test. So before that we can say the one result. If you look about this function, this is nothing but my uniform distribution, because I take 1 by 8 as of the total. If you have the k is any continuous random variable, this is the any continuous random variable with the CDF is here, and you can define any of the u which is a function of the x, then u is a uniformly distribution over 0, 1. How you can say that? If you have the continuous random variable, all of you know that this is my CDF. How you can define the CDF function is 0 whenever x is less than 0, have some function whenever it lies between the two domains, and whenever it's infinity, near to the infinity, it's a 1. So whenever x approaches infinity, so it will goes to the 1, otherwise it's a 0. Now here it is a continuous function, so if you take any of the point here, I call as x of u, corresponding to this point, you always define one point on this function of here, say u. So that is, if you consider u is any number which are lies between 0, 1, and x is a continuous function, so there exists x of u which belongs to the R, such that f of u, this is the graph of the f of x. So there is a function, there is a point here corresponding which you can define as a u, as shown in here. Now how you can define the uniform distribution? We can define from the CDF of this. This is the definition. What is the value of the u is nothing but my f of x. I can substitute here. What is the capital F is? Capital F is my CDF, which is always with a continuous function. So we can say if f is a continuous function, then we can write like this way, because f is a CDF which is a continuous. So how I can write? This is f of u. What is the f of u is? Corresponding to this is nothing but my u. How you can say that? This I can write this function as of this value. What is that? This is nothing but my CDF of the uniform distribution. So once we will know that it's a uniform distribution, now we can define the Ks approximation to the null distribution. What is the meaning of that is, if you have, this is my empirical distribution, this is the distribution which is given to you. If you take the subtraction of them and take the supremum, we will call as the Ks statistics are there. What is the meaning of that? This n is depending on the number of the data set belongs to it. If you have the continuous CDF and xi's are my sequence of the IID, then whatever the CDF you have, this dn does not depend upon the PDF of the CDF. What is the meaning of that? This is nothing but my non-parametric distribution, because if your test statistics does not depend upon the distribution function, that is called as the non-parametric. So it depends only on the number of the independent random variables. Also, if you take as n as infinity is a very large, then this is asymptotically Ks distribution with the CDF. This is the CDF of the Ks distribution, or you can say this is the definition of this. If you take, this is the limiting distribution, this is the definition of the CDF, which is nothing but my KOX. Based on this small introduction, we will see there are the two Ks tests are there. This is one is the one sample and second is called as the two sample. We will see in this lecture. One called as the one sample, if the number of the observation in this is less than 40, we call as the small sample, otherwise a large sample. We will discuss about the three-step rule, how you can solve them. Step 1 is that define the hypothesis, compute the test statistics, and finally we will take the conclusion. How you can define the test, how you can define the hypothesis is, our null hypothesis is there is no difference between their empirical distribution, that is the F0, and the theoretical distribution. Theoretical distribution is always given to you. Your target is to find the empirical distribution. Once you are defining the H0, how you can define the H1? Since there is no difference between them, what is the opposite of this is, there is a difference between them, that is called as the alternative. Once you will calculate the empirical F0 and the Fn, we will define the test statistics by using of here F0 minus Fn, take the maximum of this. Whatever the value you can compute them, we will take the conclusion based on the critical value. We can compute the critical value based on the Ks test one sample table. You can easily take from the any of these statistics books, or you can simply write on the Google as the Ks table critical value. Once you will write in, this is the table you can see on the Google or the book. You can see based on the value of the alpha, level of the significance, and the value of here, you can get the values of the critical value. Also, you can see whenever n is my greater than 40, then the critical values are obtained by using this according to the level of significance. How you can reject them? So we will reject them. Whatever the value of the D, we will compute from the step 2. If it is greater than of the critical value, then it is rejected, otherwise may be accepted. So we will see some examples are there, how you can solve them. Look at this first example. If you have conducted a study which is related to the different streams, and you have to look about the intention of the students to join the adventure club or not. It is expected that the 12 students from each class would join the adventure groups. That is your expected. So you have to apply the Ks test. You have to check whether there is any significant difference between them or not. So what is the H0? We assume that there is no difference between the students of joining them. Then this is my step 1. How you can define the step 2 is, our target is to compute F0 and Fn, and then here. This is the stream which is given to you here, BSc, BA, BCom, MA and MCom. These are my theoretical distribution, these are my expected distributions, and this is my expected R here. So I can write these values here. This is my observed distribution, this is my theoretical. Now you can compute the F0, that is observed, 5 divided by 60, that is my here. So since this F is my CDF, so firstly you can write the CDF of this. This is 9, 5, 14, then 25, then it's a 31, then it's my 19, it's a 50, and so on. So you can write like this. So this is a 9, this is a 14, this is a 25, this is a 41, this is 60 divided by the total R there. Similarly, you can define the value of the Fn. This is the theoretical distribution. So what is the CDF of this? This is the first 12, then 24, then 36, then 48, then 60. The total is my 60. How you can define the CDF is, this is 12 by 60, 24 by 60, and so on. These are my here. Remember that this is my CDF, that's why it's a cumulative. Now once you know the F0, once you know the Fn, you can take the another column called as the, I called this as of the D, which is computed like this way. Now I want a maximum of this. Which one is a maximum? You can easily see that this number is my maximum. So the answer of this is my 11 by 60. This is my step number 2. Now step number 3 is you have to take the conclusion. So for that, since what is the value of the n? This is 60, which is greater than of the 40. What is the meaning of that? You have to apply the large sample case test. Once it is a large sample, then you have to find the critical value. What is the rule for the critical value is here. How do you know that? Since it is a 5 sample, you can see at the level of the 5% level of significance, and the value of the critical value is whenever n is greater than 40 is 1.36 divided by root n. Since n is my 60, you can substitute here. Now when you can reject these, when you calculate d is greater than of this number, is it true? What is that? This is my greater than of this, that's true. It means we can reject the null hypothesis and conclude that there is a difference between their streams. Look at the another example are there. If you have some observations, and do you have to evidence that there is any, they are not randomly sampled from the uniform distribution. Now in this case, it is instead of the uniform, it is instead of the expected, there is a uniform are there. Again, your target is here h0 and h1. What is the fx and the what is the f0 is? Fx is the unknown CDF from which our data is sampled. F0 is my empirical distribution, which is given to you as of here, where fx is my this. Now how you can find the, firstly we will try to find the f0. Since it is a uniform distribution, so we all know that the PDF of the uniform distribution is here. How you can find the CDF from the uniform distribution is by using here. So you can say that it's from 0 to x of half of this. So what is that? This is nothing but my x by 2. Whenever it lies between 0 to, otherwise 0 and 1. How you can define the f of 0? Since it is an unknown distribution, so how many numbers are there? You can see these are the 3, 4, 5, 6, 7, 8. So 8 numbers are there, so your empirical distribution is k by 8. Once you know the f0, once you know the fn, our target is to define this value. So we can compute the fn, we can compute the f0 and then difference. We can see here fn is my k by 8. So k is my this, so it will be my 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8 and then so on. So you can see this is my 1 by 8, 0.125 and then so on. You can compute the value of the f0 by here. This is value of the x. 0.26 lies in between them, so it's a 0.26 divided by 2, it's a 1.13. 0.33 again lies here, so it is my 0.165 and so on. So you can compute like here. You know the CDF of this, you can take the difference of this, we will get the value here. Now you want the maximum value. Which one is the maximum? You can easily see this number is my maximum, that is my 0.145. This is my step 2. Step 3, since n is my 8, which is less than of the 40, so we can use the small sample case test. The critical value at the 5% level of significance is here. How do you know that? Since n is my 8, level of significance is 5, you can see the level of significance is here. K is my 8, the level is my 0.454. So you can see I have written as a 0.46 up to the 2 decimal. Now you can compare this number with here. If it is greater than, then we can reject it. Since capital D is less than of this, so we fail to rejected the H0, that is we may accepted H0. What is my H0 is? There is no difference between them, so we can say the data were distributed from the uniform distribution. Look at the another example is there. Again the similar kind of the questions. Here we assume that data is distributed normally or not. Last question was on the uniform. Again your things are here. What is my fx? And that is data is normally distributed, it is not. What is the fx is? Unknown distribution, that is given to be here. F of 0 is my CDF, which are distributed from the mean and the standard deviation. So since standard deviation is 10, the variance is my 100. How you define the f0 is? We all know here. Once it is a normally distributed, we have to convert them into the terms of the z. We can written like of this x minus mu by sigma, that is of the phi. How you can define the f of x? This is nothing but my, since how many numbers are there? Since n is my 10, you can see here, so the k is my. This is my step 1. Now your target is to compute this. How you can define the f of n? This is my k by 10, so it is my 1 by 10, 2 by 10, 3 by 10 and then so on. How you can define this value? You can substitute, this is my value of the x, 108, 105 here, so it is my minus 15 by 10. So you can see the CDF value at minus 1.05 from the normal distribution table. So it is lies here and so on. Once you compute these two tables are there, now you can subtract them, you will get the maximum value as of these two are the maximum values because the numbers are same, this one. Here n is my 10, which is a less than of the 40, so again a small sample will be there. We can compute the 5% level of significance. You can see this is my 10, level of significance is 5, so 0.409, that is a 0.41. You can compare them, 0.350 is less than of the 0.1, so we can reject, we fail to reject it, means we make accepted the H0. So we can accept it the H0, that is the data are informative from the normal distribution. Now we can see how you can solve the KS2 sample test. That is, if you have the two sample and each of the observations are less than 40, we call as the small. If either of one is greater than 40, we call as the large sample. Again, the rule of behind is that we have to check agreement between the two cumulative distribution, that is corresponding to the Fn1, second is Fn2, that is by here. Again, the same rule behind that, if you have the two different samples consists of the different numbers n1 and n2 having the CDFs are Fn1 and Fn2, then we can define the statistics as of this. Instead of the F minus F0, we can define like this way, and again it instead of the root of the n d, here is a, since there are two samples, it follows the KS distribution functions. Now how you can solve this problem? Again we will follow the same step rule. In here, instead of that, here what is the step 2 is, we can use the step 2 by using this supremum. That is here, what is that? We can find the value of the d by using this. We can take the KS2 sample distributions, critical values are here. The upper values are represent for my 0.05, while the lower values like here, these are my 1% level of significance. This is for the small sample. However, whenever there is a large sample, we can use this critical value where C of alpha is depending upon the level of significance like here. We will see in the couple of examples so that you may understand. Now you can see there are the two different samples are there, since the number of elements are not same. So firstly, you can say whether H0 and H1 as of this F1, F2. Now based on this F1 and F2, you can firstly write all those informations like of the 2, 3, since more than 2, 4, 5, 6, 8 and 9. So I can write like this way. How many students in the university 1 consists of the 2 units? So how many? There is only 1. So 2 is as a 1. How many 3s are there? These are the 2 numbers. 3 is written as a 2 and so on. So I can write like this way. Why 4 is a 0? You can see there is no numbers which belongs to the 4. You can see there is no 4 are there and so on. Similarly, you can define as a university 2. Now how you can define the CDF? Since total numbers are my 8, so you can find the CDF of this. This is 3 plus 4, 4, 4 plus 7, 8. How you can define the CDF of the first is 1 by 8. Now it's a 3 by 8, it's a 3 by 8, 4 by 8 and then so on. You will get the CDF of the this, CDF of the this. Once you know the F1 and F2, you can put them here. You will get this value. Which one is the maximum? You can easily see here is the maximum value are here. Now both the values are less than of the 40, so we can use the small sample. You know the critical value of this N1 is my 8, N2 is my 7. You can take the critical value as 40 by 56. How? You can see from this critical value table, N1 is my 8, N2 is my 7. So which at the level of the 5% level is my 40 divided by 56. So 40 divided by 56 is my level of significance. You can see here this value is nothing but. Now you can compare this value with here. Since this value is my less than, so we implies null hypothesis is not rejected. That is, we can say we can accepted the H0. That is, there is no significant difference between the distribution of the two samples. Look at the last example are there. Again, you have to say there are the two groups are there. Again, you can see H0 and H1, they are from the same distributions. Now here there are all are my unique numbers, same number of the elements. You can write like this way. Again, total numbers are my 80. You can define the cumulative firstly. It's a 4, it's a 15, it's a 20, and then so on. You can define like this way for this men. Similarly, for the women's, you can define the cumulative are here. You can take the difference of them, and what is the maximum value? You can see that this is 0.2290. Both the numbers are my greater than 40, so it's a large sample t-test, a large sample KS test. We can compute the value here. What is the level of significance is? That's a 5%. So this is my alpha is 5. So this value is my 1.36. Square root of what is the n1 is? You can see how many numbers are there, 80 and 62. So we can substitute this value as of this value. Now you can compare again with the same rule. We can see this is again less than. So again we are not rejecting the H0. Therefore there is no significant difference between these samples. So this is the way you can solve this KS test either as a one sample or as a two sample with the help of the simple 3 steps rule are there. We will see in our class another this. If you want to find some another videos related to the sine, Wilcoxon and all these known parameters, you can simply browse this YouTube channel link, Dr. Harish Garg. This is the link. You can simply share this video with your friends. I hope you can enjoy this session too. Best of luck students. Happy learning.